All right, we're going to start on section 2.2, the algebra of functions. And I want to be clear that this is going to be something different from the composition of functions. We need to make super clear on which is which. In this case, we're talking the algebra of functions, where we find that our f plus g function, depending on the x, is going to be the same as f of x plus g of x. And my f minus g of x is going to be the same as f of x minus g of x, and so on. The only one that's really particular is this g of x in the denominator cannot be 0. We know that we can't divide by 0, and that's one of those ones where it's always going to be. So if we're given this formula, or these functions, let's go ahead and see what happens when we go ahead and add those together. So my f of x is going to be, let's get my draw here. So my f of x is going to be x plus 3. That's my f of x. And then plus my x squared. All right, and now I'm going to replace the 1 in wherever I have an x. So here I have 1 plus 3 plus 1 squared, which is the same as a 1. So this overall is going to give me a 5. All right. For our next one, we're going to again do an addition problem, same functions, except that this time I'm going to use a 6 instead of a 1. All right, so again, I'm going to write my generic version out, and then we'll go ahead and replace those variables with our value of 6. So 6 plus 3 plus 36. So I have 9 plus 36 equals 45. All right. In this next case, we're going to have our function f of x, which is x plus 3, subtract our g of x, which is the x squared. So, and then we're asked to solve it for 1. So here I have a 1 plus a 3 minus 1. So this is going to give us a 3 as our answer. Similar process. Here we're going to have the f minus g of 6. I'm going to have my x plus 3, that's my f of x, minus my g of x, which is an x squared. And I want to make sure we're real clear on the fact this is saying the opposite of whatever's inside here. We want to be super clear that we are doing this piece first and not saying negative x times negative x. That's not a negative x times negative x. It's subtracting x squared. So there is a difference there, and you need to be careful of that. All right, so going ahead, substituting in our 6 for our value instead of our variable. We're going to have 6 plus 3 minus 36. And that's going to leave us with a negative 27. All right, in this case, we're asked to multiply, and I have x plus 3 times our x squared. And then we're replacing all of our x's with a 1. So I have a 1 plus a 3, and then we're going to multiply by a 1 squared. So we have a 4 times 1, which is just a 4. Similar process for our 6. I'm going to have a 6 plus 3. And I'm going to have a 6 squared. So I'm going to have a 9 times 36. I think if I've done this right, it's going to be 315, but let me quick double check. All right, 36 and 9, that's going to be a 54. I think maybe it's 25. So 3 times 9 is 27. Yep, it's a 25, not 35. So 325, or 24. Oh, getting ahead of myself here. All right, so 54, so yeah, that would be a 4. So 24. That's a 24. All right. So in this next case, we're asked to divide. Remember, division is nothing more than a fraction. So my numerator is going to be our x plus 3 over x squared. Now we're going to replace all the x's with 1's. So I have a 1 plus 3 over 1 squared, which is going to be just a 4. And then here I'm going to have the same process, only this time I'm going to use a 6. So I've got a 6 plus a 3 over 6 squared. So I've got 9 over 36. And that's going to be a 1 over 4, right, when I reduce the 9 out of both of those. All right. We're going to talk a bit about difference quotients and our instantaneous rate of change versus our average rate of change. I want to talk about that, though, in a separate video since this is getting a little on the long side.